let's do this problem right here. The question is asking find the eigenvalues of A. So first of all, to find the eigenvalues, what we have to do, so usually the general method is we set the determinant A minus lambda I equal to 0 and solve for lambda. So in this case, we know the A is given, lambda I, identity is going to be 1 0 0 1. If you multiply that one by lambda, it's going to be only this diagonal. So if I subtract this from A, that's going to be 0 minus lambda and 1 here, and also we are going to have 1 0 minus lambda. So this is going to be determinant, and I have to calculate this determinant equal to 0. If I want to find the determinant, so let's simplify furthermore. So this is going to be minus lambda 1 minus lambda. So this is determinant equal to 0. Now I can find the determinant. So since this is a 2 by 2 matrix, I can find the determinant by doing AD minus BC. So AD is going to be lambda square minus BC is going to be minus 1 equal to 0. And if I find lambda square is going to be 1, therefore lambda is going to be equal to plus or minus 1. So we can say lambda 1 is equal to 1, lambda 2 is equal to minus 1. So these are the eigenvalues. That's the answer for the first question. So let's do the second question. They are asking for find the orthonormal eigenvectors of A. So first let's find the eigenvectors. So to do the eigenvectors, what we do is we set this A minus lambda I. We bring this one and set this one into null space. So if I do this one, set this one into null space, it's going to be something like this: minus lambda 1. This is also 1. So this is 1 minus lambda, and that's going to be 0 0. So this is the null space, right? So first of all, I'm taking this lambda 1. So lambda 1 is equal to 1, and let's solve this. So if I plug this one into here, for the lambda it's going to be minus 1 1 1 minus 1 0 0. And if you see, these are linearly dependent. If I add them together, this will become 0. So therefore I can say minus 1 1 0 0 0 0, because this is R1 plus R2. And if I want to, if I want to do the Gauss-Seidel fully, this is going to become 1 minus 1 0 0 0 0. Now I can write the equations. It's going to be x minus y is equal to 0. We know that y is the free variable because this doesn't have any pivots. This column doesn't have pivots. So y column is the free variable. Therefore x is equal to y. I have to write in everything in terms of free variable. Therefore let's call the first vector v1. So v1 is, so eigenvector v1 is equal to y comma y. I can take the y common. It's going to be 1 comma 1. You can write this one as span of 1 1. Or sorry, you can write this one as basis of 1 1. Then that's all about it. And now we have to find the orthonormal. So first of all, to find the orthonormal, this has to be orthogonal first. But is this orthogonal? Yes, it is. Because if you see the matrix, this is a symmetrical matrix. So whenever you have a symmetrical matrix, that's already orthogonal. So you don't have to find orthogonal separately. This is orthogonal already. So to find the orthonormal, what I have to do is I have to divide this one by its magnitude. So what is the magnitude of this one? 1 square in the square root. So it's going to be square root of 2. So if I multiply, so orthonormal, therefore orthonormal vector is going to be equal to 1 over root 2 multiplied by 1 comma 1, and that's how we find the orthonormal. And that's for v1 and orthonormal v1. And then let's do the lambda 2. So we did for the lambda 1. Let's do for the lambda 2. Lambda 2 is equal to minus 1 if I plug this one into this equation, minus lambda, so minus minus lambda is going to be plus 1, minus minus 1 is plus 1, 1, 1, 1. So from by the loop we can say this is linearly dependent, so we can eliminate one of them by simply multiplying first one by negative 1 and adding with the second one. So this one becomes 0, 0, 0, 0, and we know this is the free variable because y is free variable because this column doesn't have pivot. Therefore, this is free variable. So I have to write everything in terms of free variable. So this the equation is going to be x plus y is equal to 0. Therefore, x is going to be equal to minus y. And if I write v2 eigenvector v2 is equal to minus y comma y, and I can take y common. So if I take y common, it's going to be minus 1 comma 1, and I can write this one as span of minus 1 comma 1, or I can write basis of minus 1 1. And also this is also orthogonal because we are getting everything from the same matrix. So this is also orthogonal. To find the orthonormal, I have to divide this one by its magnitude. The magnitude is going to be minus 1 square plus 1 square square root. So it's going to be square root of 2. We have to divide this one by that to find the orthonormal. So let's do the orthonormal. Therefore, orthonormal vector of v2 is equal to basis of 1 over root 2 times minus 1 1. So this is the orthonormal. Now let's move to the this is also for the second question, and let's move to the third question. C part is A is diagonalizable. The answer is yes because C. So we are doing the C right now. This part is B. This part is B basically. B. So we are doing the C right now. C is diagonalizable. Yes, because if you see the equation, the algebraic multiplication is 1 for each of them, right? Algebraic multiplication is 1, and geometric multiplication also 1 because algebraic multiplication basically means is this value repeating again and again. For example, we only have lambda 1 time. If you have this one twice, that means algebraic multiplication is 2. But in this case, both of them are just 1 time, right? Therefore, this is algebraic multiplication of 1. The geometric multiplication depends on the free variable. So in this case, we have one free variable for both of them. That's y. So that's one geometric multiplication for both vectors. So algebraic multiplication and geometric multiplication are equal for both vectors. Therefore, this is diagonalizable. Yes, the answer is yes. And they are asking to calculate a power 1 over 1. So we have to. There's a formula for this. That's a is equal to PDP inverse. That's basically derived from P inverse AP is equal to D. So we can multiply the P and that's going to multiply other side. So that's basically it is. And from this one we can say A power 1 over 1 is equal to P D power 1 over 1 P inverse. So what is P and D? P is basically the basis of vectors. So basis of vectors, but in this case I am choosing the orthonormal. There's a reason for that. Let's see what is the reason. So first of all, I'm taking the lambda is equal to v1 vector. So if I take the v1 vector, I'm taking this orthonormal vector. That's going to be 1 over root 2, and if I take v2, it's going to be minus 1 over root 2, 1 over root 2. Then what is the d? D is basically the eigenvalues corresponding to this one. So we have to respect the order. So if we write lambda like v2 first, we have to write lambda 2 first. If we write v1 first, we have to write lambda 1 first. In this case, we choose the v1 first, Therefore I have to write the lambda 1 first. It's going to be 1, 0 and 0, and this is going to be negative 1. So this is my P, this is D. Now we need to know what is P inverse. P inverse. So whenever we have orthonormal vector, the P inverse is going to be P transpose. This is equal to P transpose because it's only work for the orthonormal, not for the other things. That's why I chose the orthonormal vector right here, because it's easy to find the P inverse. We don't have to calculate Gauss-Jordan or other things. We can directly transpose this one. That's going to be the P inverse. So let's do this. So if I transpose this one, what's going to happen? This is going to be 1 over root 2 minus 1 over root 2, and this is going to be 1 over root 2, and this is going to be 1 over root 2. And we have the P inverse right now. Now I can simply find the answer by plugging it. So P A power 1 over 1 is equal to P. P is going to be itself 1 over root 2 minus 1 over root 2, 1 over root 2, 1 over root 2. Then what I can do, maybe I continue here. I don't have enough space over there. Erase this one. Okay. So now we have enough space. So let's continue here. So A power 1 over 1. A power 1 over 1. So A power 1 over 1 is basically P power 1 over 1, P inverse. So we know that P inverse is P transpose. So we can, so first let's put the P right here. So it's going to be 1 over root 2 minus 1 over root 2, 1 over root 2, then 1 over root 2 right here. D power 1 over 1 is going to be simply the power of these things. So it's going to be 1 power 1 over 1, 0, 0, minus 1 power 1 over 1. And then we put the transpose here. So whatever the transpose we found is 1 over root 2, 1 over root 2 minus 1 over root 2. Then we are going to have 1 over root 2, 1 over root 2. So now we have found this one. Now what I can do is, maybe it's easy to find these values, right? Usually if we have other numbers, we just leave it as it is, but in this case it's simply 1, so we can calculate it. So we can simplify it a little bit more. So let's do this one. 1 over root 2 minus 1 over root 2, 1 over root 2, 1 over root 2. So in this case 1 power 1 over 1 is going to be simply 1, 0, 0, and minus 1 power 1 over 1, it's an odd number. So odd number means it's going to be negative. It's negative, and this one is going to be 1 over root 2, 1 over root 2, minus 1 over root 2, 1 over root 2. Now I can multiply these two together, so it's going to be first row, first column. So if I multiply this one by this one, 1 over root 2 right here, 1 over root 2, and so 2 by 2, we are going to get the answer also 2 by 2. So 1 over root 2 times minus 1 over 2, 0, this 0, and the second, first row, second column, so 1 over root 2, this 0, minus 1 over root 2 times minus 1, it's going to be plus 1 over root 2. Then we have second row, first column, 1 over root 2, this is 0, so it's going to be 1 over root 2. And second row, second row, second column, 1 over root 2, 0, minus 1 over root 2, so it's going to be minus 1 over root 2. So this one multiplied by 1 over root 2, 1 over root 2, minus 1 over root 2, 1 over root 2. So this is pretty enough to give it as the answer. We don't have to simplify furthermore, and that's all about it. So this is the answer for A power 1 over 1, and that's That's it. I hope you guys liked this video. See you next time.